Very good evening to you all. First of all, I'd like to welcome our chief guest and Professor Tamban sir to the dais. As you all know, this evening is really special to the research community of IIT Madras, as it marks the onset of Research Scholars Day. We call it RSD in short. RSD 2016 will be by far the biggest and the best RSD ever. This time, we are taking a giant leap with respect to all aspects of RSD. It's said that mathematics is the mother to all sciences and technology, and rightly so. It fits the occasion to start our pre-RSD lecture series with a lecture on a topic in mathematics. It's like a Madhura Vandana, which means paying respect to the mother of all sciences. The dais is honored with the presence of two eminent mathematicians in the country. Our guest, Professor Rajeeva Laxman Karandikar, sir, and our very own Professor Tamban Nair, sir. Rajeeva sir received his PhD degree from Indian Statistical Institute, Calcutta in December 1981, which was followed by a postdoctoral research at University of North Carolina, Chapel Hill, under Gopinath Kalyanpur. He spent 3 years as a visiting professor at University of North Carolina at Chapel Hill and returned to Indian Statistical Institute, Delhi in 1984 as an associate professor. He became a full-time professor within the next 5 years. In 2006, he moved to Crane Software International Limited as executive vice president for analytics. In other 4 years, he moved to Chennai Mathematical Institute, and presently he is the director at CMI. His research interests include several areas of probability theory, option pricing theory, psephology in the context of Indian elections, and cryptography. So I welcome our guest and also Tamban sir. Tamban sir, as we all know, is the head of the department, Mathematics, IIT Madras. I welcome him as well. To put it most concise, Tamban sir's area of research would be spectral approximation, operator and integral functions, regularization of inverse and ill-post functions. So without further ado, I invite Tamban sir to welcome our guest with a fruit basket and preside over the function by sharing a few thoughts. Tamban sir, please. Please give a loud round of applause. So I invite Tamban sir for a few words.
It's very nice that in this evening, lots of research scholars are coming together. It's a very rare occasion. I think this function started about three years ago. I think 3 or 4 years ago. I remember I was a board of academic research. That time, this we should have some function like this. So all the members, supported this idea, and then now for the last two years, I think, right? 2 years it has been going on, and especially a subject like mathematics and statistics. Most of you, I think, about 97 or 95% of you are, 98% of you are non-mathematicians. I think I can see some people either 4 or 5 or 6 from mathematics department. And today we have one of the eminent mathematicians and statistician in the country, Professor Karandikar here, director of Chennai Mathematical Institute. All of you are waiting for his talk on okay, what is the topic here? Yeah, big data and statistics. So I welcome you, sir, and then also I welcome all of you for this function. Thank you.
Okay. Yeah. So let me start. Yeah. So thank you for the invitation and for the kind introduction. Today I have chosen not to have any presentation and a freewheeling talk. So feel free to interrupt me, and if you have a question anytime, of course at the end I will be happy to answer questions. So statistics has been there and has its uses in various areas, especially of applied science research over centuries, and it's in recent times that statistics, relatively recent times that statistics got applications in business area. In last 2-3 decades, the interplay with business and statistics increased, and of course, current times with the availability of data, in many problems you have tons of data, and then you have techniques related to artificial intelligence or machine learning or so on and so forth. And there are folks who believe or who propagate that with so much data around, who needs statistics? Okay? The data will speak for itself. We don't need any statistics. You have tons of data, terabytes of data. In fact, storing and passing the data through is more of a challenge. So there is no need for statistics, no need for any model. See, traditionally statistics has worked with, you understand the phenomena, you model the phenomena, how the data is being generated, then you look at the data and then you make an inference or decision about the phenomena which is generating the data. And one stream of thought says that once you have these terabytes or data being generated, you can throw out all models and just infer from the data itself. And I'm going to talk on this aspect. Of course, you can guess which way what I'm going to say, but not just because I am a statistician, I am going to say that no, statistics is relevant, but with arguments and with reasons. It is true that there are many applications of these techniques, whichever broadly we can call statistics, machine learning, big data, analytics, whatever. There are aspects where you don't quite need a model or understand the phenomena, and just crunching out the data can give the answers that one is looking for. But there are situations where that is not going to work. And that is a pure data approach, how it can lead you to erroneous conclusions is the theme that I am going to talk about, and that will stress that in some problems at least we need statistical ideas, not necessarily the statistics that I learned or I teach, okay, but the statistical ideas behind the whole theme of statistics. That is what is relevant, still relevant when we are trying to do what today is being called analytics or data science. New terms have coined data science, data scientist, okay, but I look at it as old wine in new bottle. You know, the big corporation, they need to justify a new budget, okay, so they have to come up with new things. No, we have some statisticians around, but now what we need are data scientists. So it's more of that, a hype. But today we are going to talk not about the hype, but background. So many of you may have used statistics in some way or the other, or large number of you may be aware of this thing called regression. How many of you are not aware of regression? What is called statistics regression? Okay. So regression is a most used statistical tool in situations where you have two variables, y and x. Okay, x is easy to observe, y is difficult to observe, but it is y that you are interested. Okay. So in a controlled experiment, you create a relationship between x and y, and then in practice you just measure x and infer y from this. So I'll give you an example. You're all aware that drinking and driving is not allowed under law, but where do you draw a line? If you have had a drink at 4 p.m. and you are driving at 9 p.m., is it allowed or not allowed? How is it defined? Or you had yesterday, is it today driving allowed or not allowed? How do you draw the line? So the law specifies a certain alcohol content in your blood by percentage. If it exceeds that percentage, then you are drunk and you are violation of law. And if the alcohol percent in your blood is below that threshold, you are fine. But now imagine a police team standing on the roadside, stopping a car and pulling out a driver and taking out blood from the hand. Is going to cause more havoc because the hygiene and the infections and so on and so forth, right? So that is not allowed. So how are you going to measure the blood alcohol content in the bloodstream? So what has been done is that under controlled conditions, well, some of you would have liked to be the subjects in such a controlled experiment, but a measured quantity of alcohol is given, and the subjects have to sit there for a required amount of time, 1 hour, 2 hour, whatever, or every 30 minutes they will measure how much is the alcohol content in the bloodstream. They'll take your weight, and then they'll see the graph of how the alcohol content is dropping in the blood, and at the same time they'll take a sample of your breath. As you are breathing out, you close your mouth, and as you are breathing out from your nose, that sample of the output of the is taken, the air which is trapped, and analyzed. So in my example, X is the percentage of alcohol or trace of alcohol found in your breath, okay, and Y is the percentage of alcohol in your bloodstream. So in the controlled experiment, both X and Y are measured, and they'll take a diverse population of across ages and across weights and so on and so forth, and that data is used to build a relationship between X and Y. You will not get a perfect relationship, but if X is equal to something, what is the best predictor for Y? Okay. This kind of statistical model is built, and then it is instrumented. On the instrument, it is beautiful. They take a breath and it shows you are in violation or non-violation, but it is based on a model. It has not measured, it has not taken the blood sample, and yet it is declaring that you are in violation. So it is predicting based on your breath. Okay. So this is a concrete example of this thing known as regression. Now the word regression itself has a very interesting origin, and that's why I am coming from. Going back more than 100 years ago, a famous scientist in UK, Sir Galton, he did some data analysis at that time, and he measured heights of fathers and their son, grown-up sons, not children, but once the son is above 21 years. So he picked a large number of such pairs, father and son, where the son is about 21 years. And then he looked at the data, and he found he wanted to build a model that you feed in father's son and you predict how tall the son is going to be. Okay. And his finding was that invariably, if the father was above the average height, the predicted value of his son's height will be less than father. And if the father was well below the average height, the predicted height of the son is going to be more than the father's height. So he made a hypothesis that in every generation there is a tendency to regress to the mean. Okay, you may be tall, but your son will be shorter, and then son will be further shorter, and over time his theory said that everybody will reach the same height. So he called this phenomena regress to the mean. And he gave a lecture on this at Royal Society meeting, etc., etc. There is a paper which is available on the, you search regression, Sir Galton and Royal Society, etc. You will be able to get this paper. So he argued it is purely based on data analysis. That was actual data, no manipulation, nothing. Okay. The interesting thing is that some years later, someone else looked at the same data. And he says, okay, let's do the other way. Let's take the son's height and predict what is the height of the father. Okay? And he found the same thing. If the son is far above the average, his father's predicted height is going to be less than the son's height. And if the son is way below the average, the father's predicted height will be above the son's height. So initially it felt like a paradox. Okay? On the average, the son is closer to the mean than the father, and on the average, father is closer to the mean than the son. What is this? So it is to do with, when you are saying the best predictor, what criteria you are taking is different. Amongst all possible sons whose father had a height 6 feet, what is your best, on the average, what is the height of the son? So the average actually comes down. So same data set, when you just view it too differently, you get what looks like contradictory conclusions. So this is one example where what seems like a very reasonable thing to begin with, process, leads to a conclusion which is completely erroneous, but that word regress has remained and it is still called regression. Okay. So this, what is the, when you are saying the best on the data, what criteria you are using becomes important. What kind of relationships are you trying to, this is called fitting a regression line to the data. Okay. One of the simplest statistical procedures in such situations, because in large number of cases we are with this X and Y. In fact, in some physics practicals in school days also, we essentially try to plot the points and try to fit what, that time we may do it visually, what is the line which is fitting the data the most. So it is that kind of a thing which is regression. So what we take away from this example is that you have to really understand when we are saying that data speaks for itself. What is it that we are, what question are we asking for the data? The two questions were entirely different. For a father of the height 6 feet, what is your best prediction for the son's height? And the other way was, if the son's height is 5 feet 8 inches, what is your best predictor for the father's height? So the two questions are different. Okay. And misunderstanding of this can lead to, it does lead to erroneous conclusion. Another very important aspect is to understand how is the data collected and generated. Okay. So once again, let's talk from a concrete example. Let's say someone has collected data from various hospitals about cancer patients. Okay, some degree of their whatever illness, on some scale it is measured. The medicines or the treatment that is being offered, and let's say the data is only about patients who are not surviving anymore. Okay, so data generated over a period of time, and what is recorded is, was the death attributable to cancer? Okay. So now if someone just analyzes it blindly, cancer patients, okay, and did they die of cancer? Now you may reach a conclusion that those who did not die of cancer, they were actually, cancer was cured, because they didn't die of cancer. But what can happen is that the cancer is not cured, but they died earlier because of some other reason. Okay? So data is not capturing whether the cancer was cured or not. Data is simply the one you have obtained. The data is simply saying, did they die of cancer or not? Okay? So now this is, in statistics, this is going to give you a wrong conclusion. This is called data with competing risks, two different risks. There is a cancer risk. You may be cured because of cancer, or you are still continuing with the cancer, but you meet an accident and you die, or you have a heart failure, or you have some other ailment. Okay, you die because of some other reason, and that is what gets recorded, does not mean that your cancer was cured. Whereas blindly looking at the data, someone may conclude that the cancer was cured, and may say that no, death rate due to cancer or the cancer is prevalence rates are much lower than so on and so forth. So giving a thought as to, this is called censoring. You have got censored data. You don't have further data whether it was cured or not cured or whatever, because the person died for some other reason. Okay. Now in practice what happens is, often the data you collect is censored on some other parameter, and if you are not aware of it, you are again likely to get a wrong conclusion. Okay. Now, as was said in my introduction, one of the areas I have been actively working over last several years has been opinion polls and psephology. So I'll give you an example from there. in 2014 Lok Sabha election, in run-up to that, there had been a lot of interest on it in social media, okay, lot of activity. And some people even suggested that, why do you want to spend so much money now in conducting a nationwide opinion poll? You just buy the data from Facebook and Twitter and so on, WhatsApp, and analyze that. After all, that is what is being done by lots of corporations today. Just get data from these sources and analyze that rather than conducting a market research about brand penetration, brand liking, blah, blah, blah. Lots of things are being today done by just buying data from Facebook, Twitter, WhatsApp. Now, we didn't buy, but there was a lot of buzz around it, and we did look at some such data. But I can tell you that if one had to go by the data on social media, the prediction would have been that Mr. Modi and BJP are going to win 450 plus seats out of 540. The reason can be money, because firstly, in all such things, this data is being generated by a small cross section of the society, whereas the actual election outcome is going to be based on the entire society. So this is predominantly urban, a certain age group, richer, who have access to internet, only that group. Okay. On top of that, it was not even an unbiased opinion of that group, because we were reading otherwise in the media, and it is well known that as a part of election strategy of BJP and Mr. Modi's campaign team, they had a big team which was very active on social media in pushing their views. Okay. So, nothing illegal about that, but if you take that data as sacrosanct, after all, it's a large amount of data. Okay. You just close your eyes. You don't know. This is data about election. I will just analyze it and get my answers. If you do that, this will be a problem. In fact, not just social media, but people ask, why do you have to spend so much money and time in doing opinion polls? You put a poll on the website, get people to vote. You will quickly gather, just run a program on your television channel, a few slides, and you say, go to this website, vote for it, just like you vote for Indian Idol or Saregamapa or any other such programs. You advertise and get people to vote for, whether it is this party or that party, and you will have generated data in quick time at much lesser cost. Well, the problem again is the reach of this tool will be limited to a cross section, and only a certain type of people are likely to go and vote. Okay, those who have extreme views, extreme like or extreme dislike, they are the ones who are likely to go and vote on such a thing. And those who are moderate, they may be for or against the motion or against the question which has been put, they are unlikely to go and vote. Okay. So, in fact, any such poll, some sites conduct everyday poll and publish their results. They have no meaning. It's amusement and nothing more, because only those who are interested are voting. A poll is meaningful when I take initiative to pick A, B, C. You don't decide that, 5 of you decide to come and vote and you tell me this. I can't conclude that this entire house has a certain view. Let me draw an analogy. You imagine the first time you left home from safety of your home and are moving out, either to come here or to go earlier somewhere else, and going to be now moving to a hostel, living somewhere. You are generally told, don't take things from strangers, or don't ask strangers. If someone comes and asks you, where do you want to go? I'll tell you where you want to go. Certainly you have to avoid that person. If trapped, you pick a person, okay, and ask. Never take the word of someone who comes and offers to help you. Why? Again, the same bias is being played out. When you are asking someone, you are picking, you don't know, maybe that person is also a bad person, but you don't know, you are picking amongst all, and largely speaking, there are good people around, you believe in that, and hopefully you will get a good person. But when someone is coming, just observing that, you look a bit confused and offering you to help, he could be a genuine person concerned for you, but there is a much higher chance that that person could be a crook. than finding a crook amongst just you catch one person on the street and get the help. So it's something like that. People coming and offering to vote is not the right, then you are not getting a genuine opinion. Okay? So, just somebody coming to me, sir, here is we have done a poll and here is 10 responses of 10,000. Can you analyze and tell me what it is happening? So I asked them, okay, how is the poll conducted? They said, but don't you believe us? I said, it's not a question of belief or disbelief. It's a question of how the data is generated. Unless we get to the bottom of that, you can't really interpret the data. Okay. One more example I want to give, it's historical, it's not hypothetical. It hits the nail. So, the story is from World War II. Those of you who have read older things or seen war movies, etc., from the World War II era, you'd be aware that World War II was at just around the time when air warfare had just kind of in infancy. In World War I, there was no air warfare. World War II era, the small aircrafts had just been pressed into service for war, and it was as much a weapon of destruction as a psychological weapon. So, for a while, the Germans had a head start, and their aircrafts were happily going and bombing over London and scared the hell out of the population of London. And that was playing havoc for the Allies, because Britain was the leader of at that point at least, of this group. And when the population is turning, is scared and running hither and thither, then they cannot be focusing on the war effort. They have to focus on getting the morale. All right. So they did what they could do. They also started bombing Berlin. They put together quickly whatever aircraft they could lay their hands on, and they are starting also bombing Berlin. And since the aircraft themselves were new and being in the warfare was new, there were no anti-aircraft guns. It will be amusing now, but actually people were taking the standard guns and like that trying to shoot an aircraft. Now the aircraft was also not flying as high as they fly today. These were tiny aircrafts, turboprops and so on. They were also flying at much lower heights. And people were just shooting. So, some aircraft will get hit by bullet, they may still return, some may get hit by bullet, they will fall, and they will be sent again on another sortie if they return. So, this is the story from England. So, someone in the army, or there was no separate air force, from the armed forces, let's say, they were keeping meticulous data, statistics they were compiling on amongst the planes which are returning, where were the bullets hitting. Okay. So let's say you divide the surface of the aircraft in 20 parts and you are keeping tally marks, where are the maximum hits. And after maybe a week or two, when there were enough data points, this person felt confident and he presents the report to the generals saying that, these are the areas which are being hit the most by the bullets. So we need to strengthen the metal in these areas so that the aircraft can withstand the pressure here, because this is where they are being hit. So of course, any strengthening by metal will increase the weight, and so you can't say that, just the entire plane you do. So you have to pick. Now, it so happened that a mathematician who later was a very famous statistician called Abraham Wald in US, he was not getting an academic position, and he was working with the defense forces in US, and somehow he got hold of this data and this conclusion. Now, he looked at the data and thought about it, and he came up with an entirely different analysis. So, he made two assumptions, which were valid then are no longer valid today. That people are shooting just arbitrarily at the aircraft. So every part of the aircraft, if you have divided into 20 parts, let's say, of equal surface or whatever, each of them is equally likely to be hit by bullet because people are unable to focus and aim at a particular point. Today it won't be a valid, you can focus and try to shoot at a very specific point. So this assumption will not be valid anymore. Moreover, he assumed that there are no redundancies built in. It's not like, it has 3 engines and even if 2 engines fail, one engine is enough to fly it back. It was just at the beginning, so there were no redundancies. So the assumption was that the ability of the aircraft to continue to fly if hit at a point A and if hit at a point B, these two are independent events. So these two assumptions, today it won't be valid because there is built-in redundancies. Now once you make these two assumptions, that all areas are equally likely to be hit, the conclusion that stares at you is actually you need to strengthen the areas where you are not observing any hits, because these are the equal number are being hit in every region and those are the ones which are falling and not returning. Okay? So your conclusion is going to be that you need to strengthen the areas which are amongst the planes which are returning, you see less hits. Okay? So when you put the same data in a proper model, you understand the phenomena and you put in that model, your conclusion is exactly the opposite. Of course, the story doesn't end here. No army general is just going to look at this argument and therefore change his or her mind. So this is where the conclusion you have to be able to explain in layman's term. You have to sell your conclusion to the decision maker. In this case, it was very obvious. The part which was least hit was the engine. If the engine is hit, the aircraft is not going to be able to fly and it will not be returning. So he didn't need much selling. He said, oh, because of this engine and oh, of course engine. Why are we thinking of strengthening this side or that side? Engine is the one which needs strengthening because there is no built-in redundancies. So this example really hits the nail that if you are just don't care about model, you have tons of data, you just analyze it and data speaks for itself, believe in that, your conclusion will be that you need to strengthen those points where you are observing hits among the planes which are returning. This again is the effect of censoring, because you are only observing planes which did not fall. Those which fell, you have no data on where they were hit. Okay. Effect of censoring. So from the cancer example or this example, it is abundantly clear that if the data that you have got, maybe tons of data, but the data if you have got, if it is subject to a certain censoring effect, unless you understand the phenomena and model this aspect, your conclusion that you get is going to be highly suspect. Okay. So the this entire statistical paradigm of a model and then data and the two together yielding a conclusion. This will remain. What may have to be given go by, those of you who may have done a statistics course, etc. The old era, the entire focus was the data was going to be small. So if you look at some old, not old, even some current books maybe, but certainly books which are 20 years old or 10 years old, they'll say, oh, if n, which is the sample size, if it is large, then you can use normal approximation. And then it will say, as a thumb rule, n bigger than 30 is considered large. That's what books will say. And today you are talking about n being million and billion. So the scenario itself has changed. So simply using what is not relevant is simply using some of those things which are there in the books in scenarios where you have a large amount of data. Of course, today also there will exist situations where you have only small data. Drug trials, you can't have millions of trials of a drug before you decide whether you are going to introduce it or not. That will remain inference question for small data size. But large amount of applications are having tons of data. So it's not that everything which is taught in the book is relevant in every statistical problem. But you have to pick and choose. The concepts behind it is how the data is generated. Is it randomly generated or is it subject to some censoring? Is the people who is taking the initiative to record the data, is there some incentive for them to record the data? All these things have to be taken into account before one can draw conclusions. So, of course, how many of you had heard this story about beer bottles and diapers? Anyone? So, that was touted as one of the earliest successes, so to speak, of this analytics in business. So, in US, most of the sale is through supermarkets like Spencer's or Nilgiri's here, where the entire transaction is electronically captured. When one receipt tells you that one customer came and bought, and what all items he or she bought. So that is called a basket. So one such slip is a basket. So somebody did this analysis in US and found that the two items which were most commonly occurring in a basket together were beer and diapers. And they advertised and they advised the supermarkets that, where you are putting diapers, in that thing also put beer in the corner. So when people go to buy beer, they'll see that, buy diapers, they will see that there is also beer and they'll pick a 6-pack of beer. So now, this is an example which may be true, may not, may be really valid or not valid, but the point is that there is very little cost for the supermarket in stacking some beer in the diaper lane near where diapers are sold. There is no loss, very negligible cost. So even if there is a small chance of, or a small percentage of people who are in addition going to pick up the beer, it's fine. So there are some situations where the cost measured in whatever way, okay, effort, money, loss of opportunity is negligible, and you are no big deal if you take the conclusion at face value. But there could be situations where taking the conclusion at face value may involve huge costs for you. Then, if I were the person, I will say that, we have to get deeper into this. Is there any really true, or is it just some what is called nonsense correlation or spurious correlation that is coming up? The net effect may be due to some other factor, but we are just observing this. Okay. So in the same vein, there are applications of data science or data where you implicitly believe in a causal relationship, that if you can say some x and y, and if you control x, then y will be reduced. For example, now there is enough evidence that smoking and cancer, lung cancer in particular. Okay? So this is what we will call a causal relationship. Smoking not necessarily causes, but increases the chances of having lung cancer, and thereby if you overall reduce smoking in a group of population, in a subgroup of the population, the incidence of lung cancer will reduce. So this is what is called causal. So not every observed relationship is causal. Okay? But you need little more research to figure out if it is causal. So, but there are situations where we are looking for causal relationships. But there are other situations where the end customer doesn't care about is it causal or not, as long as their business objective is met. So to give an example, when banks offer credit cards, okay, they ask some 10 silly questions. They'll ask, of course, name, age, gender, married or unmarried, do you own a house, salaried, and 2-3 other questions. That's about it. Now, on the basis of that, they decide whether or not they want to give a credit card. So, what they do, and large number of statistics graduates who work in the industry are day in and day out just doing this analysis. So, what they do is they try to fit a regression line between probability of default and these variables, and based on that they build a model. And one of the surprising thing is that if all other things are equal, this one variable, married or not, makes a big difference. Now, it's not that someone who has tendency to go on default, just because he or she gets married, that tendency is going to change. So clearly there is no causal relationship here. One can think that there is a causal relationship between owning a house and credit card default. After all, credit card, your bill may be much less, and your house, you are not going to run away from your home, leaving the home in the lurch, just to not pay the bank its due. So if you say that relationship, there is a causal relationship between owning a house and default probability being lower, there is a belief. But married, unmarried, doesn't. But that everybody's analysis throws that up. Okay. Now, but bank doesn't care whether there is a being unmarried is the cause of default or being married is the cause of less default. What they say is, if I use this variable as part of my decision making, my overall default rate goes down. Too bad you are unmarried and I am not giving you card, but too bad. What can I do? But my model says this. So here is an example where they are only interested in looking at the overall thing. They are not looking at individuals. So they don't care about a causal relationship. Okay. So the use of statistical techniques or analytics, this aspect also has to be taken into account. Whether you are looking for a causal relationship, not that observed correlations will establish cause. You need a lot more work into that. But to begin with, do you need to explore that area or not itself, you have to think about. So, and these problems are not going to be whisked away because you have got terabytes of data. Okay. How the data is generated, is there a censoring or not, will remain an important question. What is the overall, your understanding of the phenomena in the background will remain an important question. So then the question comes, so what is the space for machine learning or artificial intelligence or this model-free techniques which are there? There is neural networks, there are various other such networks. And my view is not necessarily a universally accepted view. My view is that these are exploratory steps. So perhaps to go back to the diaper and beer example, there is perhaps a deeper relation between these two, which based on our understanding of people's behavior we had not thought of, and this data analysis throws it up. Okay. So this is an exploratory step. If that was something based on which our decision is going to be very important, then we need to explore it further and really see if that is true. So the role, as I see it, is that this modern AI techniques or neural networks or various such techniques which are there, they play a role of exploratory analysis. They may throw up relationships which we had not thought of, or the modeler or the people who are studying the phenomena had not thought of and had never tried to test for, so they won't know. But these techniques throw up these relationships. Now you have to go back to understanding of the phenomena. Does it make sense or not? Okay. And then if it is making sense, you may test it through some other data techniques and use them or discard those. So these modern techniques of course have a place, and especially if it is to be inferential, you want to draw some inference out of it, then you need to go back and understand the model, the phenomena, incorporate that and come up with an answer. Without that, you may be getting a completely erroneous answer and you won't even know. Okay. So fact, about statistics itself, there are lots of jokes. There is lies, damn lies, and statistics is one of the phrases which is used. Okay, but that is, and examples are given, and that is because it is ill use of statistics which is responsible. Statistics by itself is neither great nor bad. It's a tool, and if used judiciously, it can give remarkable results. So to come back to my opinion polls, I had started off my career as an out-and-out theoretician. Okay. 15 years after my PhD, till that time, so till 96, 97, I had never done any applied work. I had never looked at any real data other than the analysis, the data that I had looked at in my MSc practicals. After that, I had never looked at any data. And in the computer era, I had never opened even an Excel sheet, leave alone any other more complex thing. And that's the time when I got engaged in this activity to do opinion polls. And it was baptism by fire. My very first applied task was to design a nationwide sample survey. And the conditions were that once I get the data, I have to analyze it and give my prediction within 6 hours. Because we want to do the poll as late as possible, and the election commission has a deadline that 48 hours before the first phase there is a clampdown. After that you cannot publish any results or any findings. So working backwards, everything was worked out that we will give our analysis. The rest of this was for India Today magazine, and the rest of the magazine will all be ready. Just these 4 pages will be remaining. And once we give that in, they will print these 4 pages, bind it, and go and deliver it 2 hours before the deadline at Election Commission headquarters to prove that it was published in time. So this was the very first thing which I did was this. And if people ask, oh, how much data sample size did you want? I said, I may want a huge sample size, but how much is feasible given the budget? So believe it or not, the total, our target was 15,000 and realized interviews were 10,000 nationwide. And that was enough to give a good picture of what is likely to happen. So a properly done, methodologically rightly done thing can give deep insights into public voting, even with a relatively small sample size compared to the population. But of course, people can go completely wrong even with lakhs of sample, as happened in the Bihar election last one. Everybody had a egg on their face. Some of them claim to have had a lakhs of samples. So the main thing I wanted to convey is that those who use or are likely to use statistical techniques in their research, you have to be aware, even if you are working on an area where there is large amount of data available, you have to ask these questions. How is the data generated? And interpret the data by understanding the background from the phenomena which is generating the data. Then you are less likely to go off the mark than you are if you just do blind data analysis. Okay? So let me stop here. Let us have some questions, and if any.
So most of us in the room would agree that it didn't feel like a traditional lecture, and it was actually an eye-opener. The examples were simple enough to dilute the complexity of the subject and real enough to relate. So with this, we conclude the lecture. We are opening up to questions, as Sir has already suggested. Yes.
Hello, sir.
Yeah.
I just want to know, how did you exactly select those 10,000 or 15,000 people for the proper opinion poll?
Okay. So very important question, and the most important aspect of opinion poll is how do you choose the sample? So it goes back to our objective is to do a nationwide prediction of seats, not individual seats. Okay. So with that, we had built a model which required us to estimate votes at state level for every state, for every party. whatever parties are relevant. So in Tamil Nadu, we would have, at that point of that 98 election, there were two main alliances, as has been the case, except the next one. And the partnerships at that time was ADMK and BJP had aligned, and Congress and DMK had aligned. So basically, we wanted to estimate the vote percentage of these two alliances at the state level. Then starting from that and the past data, we have a model which will tell me various other things, and things will follow from there. So our objective was to estimate vote shares of major parties or alliances in every state separately. So given that, what we do is, amongst the constituencies, we picked at that time 1/3 constituencies out of 543, okay, randomly. Then each of these constituencies, we get a list of polling booths. Then for each polling booth, we get hold of, so out of that polling booths, we picked, at that time we picked 4, let's say, 4 polling booths. Then at each polling booth, we get hold of the voters list. Then from that voters list, we randomly pick the required number, whatever we had worked out. Okay? And then send these people, our enumerators, door to door to those houses and get their opinion. So multi-stage selection of constituencies, polling booths, and then the actual respondents. The main thing is that we select the sample, target sample, and then the enumerators are told to just go to those doors and interview. In most surveys in India, perhaps elsewhere, but certainly in India, which are done by other agencies, they are not done at all by this method. This method is rather expensive. Even when you are given a full address, going and finding some new location is not easy in India. And here the address will be given, will be a half-baked address written in the voters list. The method most others do is what is called quota sampling, which is, they will have a, let's say they decided that in Chennai city they want 1,000 people or 500 people. Now Chennai city's population profile on various socio-economic parameters is available by census data. Rural, urban, education, caste, religion, and so on. So the agency is engaged and they are told that out of 500 people I want 275 men and 225 women, or so many urban, so many rural, so many educated, so on each of these things a profile is given. Now what they do, in those days we used to say they'll go to street corner on a pawn shop, today we'll say they'll go to a mall. Any place where large number of people are congregating, okay. Then looking at faces you figure out, okay, looks educated, looks in the age group such and such, looks rich, okay, and thereby interview and maybe take 300 out of 500 you just do by going to 3 malls, okay. Then you come back and now look at the data and see, okay, which are the groups which are underrepresented. Now you go and try to actively find those, but you just find anyone fitting that description. You don't necessarily do any randomization. Okay. In fact, there are softwares which will tell you that, you know, you have out of 500, these are the 300 you have got. Now what is the next profile you should look for? Rural, uneducated, age group such and such man. That may be the answer that may be popping up on your screen. Now that methodology can give answers and that can give you wildly bad answers, because you are not trying to, obviously when when you go to mall, you are looking at people who are tendency to shop, and those who are sitting at home are underrepresented, right? So things like that. But we don't follow that, and unless somebody is collecting data with this methodology, I don't associate with that, and I won't put my name to that.
Please, you can wait for the mic.
Sorry. Okay, I'll let you call who should answer.
So nowadays companies invest a lot in data analytics, right?
Huh?
Companies invest a lot in data analysis.
Yeah.
So, I mean, can you give an example where data analysis led the company to make a,
Oh
make
yeah.
a decision which helped it really?
Now, can make, I won't be able to give you where it made a difference, but can make. So there are many aspects, okay. So one of the areas which is the largest data generator is telecom business. Every call, so much information is recorded. Whom did you call, when did you call, which area were you, which tower picked up your, I'm talking of mobile. So which tower picked up the signal, where was the other party. So whole lot of this data is getting trapped, okay. Now, simple example, the company wants to launch a new plan, or company is now, like they did recently, some company which did not have 4G network, now they are launching a 4G network. So one thing, they will advertise on newspapers, they will advertise on air, they will advertise with hoardings, etc., etc. But they want to target customers and send them specific message or specific offers. Now it may seem that, oh, what is the problem? They can send it to everybody. But even that is internally some cost to them. So they would decide, let's say, that they want to send these offers or this thing to 10% of their customers. Which 10% to choose? So traditionally they start by first deciding that they don't want to send it to, they want to send it to high spenders, but not just high spenders. They want to send it to people who are using it for business as opposed to just chatting with teenagers chatting with their boyfriend or girlfriend. Then they may not be, though they are spending a lot of money, but they don't quite have propensity to spend a lot more. Whereas if it is a businessman, he or she may have propensity to spend more. So they want to what they call segmentation. So segment their customer base into what are likely to be business users and various such things. And that is done by simply analyzing the calling pattern. Then within each segment you figure out who is the one who is using data a lot, who is the one who is using STD a lot, or who is using international calls a lot, and things like that. And based on that you do targeted marketing. So when it comes to this notion of so-called targeted marketing, okay, that is where a whole lot of data analysis is coming into the picture. There are many aspects, internal functioning of a company, or maintenance of your hardware systems. You predict the failures and thereby save your downtime. So companies are using these techniques in many innovative ways.
Hello, sir.
Yeah.
I would like to ask question on, we do research, we don't have much kind of data for our research analysis. So what you would suggest, how we can design our research methodology or design experiment, so we can get the data, and from the data we can, do some statistical analysis that would be impact and result in our research work. So how we can design that part? Can you just, in a statistical way?
Yeah, so, very difficult to give a generic answer for this, but there are well-known statistical techniques. I was talking to one of the people here, the so-called design of experiments. So you do all possible combinations, maybe billions, and you may not be able to run those, but you run a subset of those possible combinations and try to make an inference out of that. So that's a technique called design of experiments, where you design what parameters you will set. So generic answer is difficult, but in a specific context one can look at, you have to start by what is the objective, is it feasible, and then if so, what is the best way to go about it. So where is the mic? Yeah.
Hello, sir.
Yeah.
My question is again from opinion polls.
Okay.
When you conduct opinion polls, actually, do you conduct? Do you compute the vote shares? And if you compute vote shares, then based on that, coming up with a number of seats of a political party, that may not be that correct, because there's not nice relation between vote shares and number of seats. So how do you deal with this kind of problem?
Okay, absolutely right. You have, you don't really have a very clean relationship, mathematical relationship between vote shares and seats. Actually, this depends on how the votes are distributed. Okay? So in particular, let's say if someone tells me or you that next Lok Sabha election, Congress and BJP will have equal vote shares, you can still conclude that BJP will get more votes, more seats than Congress, because Congress votes are distributed on a much wider region and BJP votes are concentrated. So one has to take into account, so this kind of how the votes for a given party are they concentrated, are they distributed, if so by how much, that we learn from the historical data. And presently where is their support level, that we obtain from the opinion poll. And the two are put together in a fairly elaborate mathematical or statistical model to get to number of seats. And actually, that is where technically my expertise is. So 2004 to 2014, that was the aspect for which I was doing for CNN IBN, and the opinion poll was being done by the Center for Studies in Developing Societies, CSDS, based on our methodology agreed. So my expertise in this vote to seat conversion, and I have spoken in IIT at least 2 times on this theme. I can speak again on another. Today I didn't want to pick the same theme because I thought maybe there is a large intersection with earlier and they will think that that's the only thing I speak. So, but I have written about it at length. At Hindu Center I had given a long talk which is still there on their website, Hindu Center's website, where I have explained my methodology. But
yeah, you gave that example of how people who give credit cards, they use correlations, but they don't bother about whether there is a causal relation or theory about it.
yeah.
Now, in the same vein, have you done any study to see whether astrology makes sense without a theory?
Okay. So I have not done, but a friend of mine and a statistician at Pune University, he actually did such an experiment of elaborately getting empaneling certain number of astrologers and asking them some questions. About people's profiles and so on and so forth. So he did do an experiment. His conclusion was that it had no correlation whatsoever. Their predictions were all over for these profiles of people. So I have not done, but at least one person whom I know and had done credible thing in Pune about this. Maybe one day you can get him to come here and give a talk about this. But Professor Gore, he is now retired, but he did experiment of this kind.
So with that interesting question, we wind up the question and answer session of the lecture. I thank Rajeeva sir once again for that entertaining and informative lecture that he gave us. I'd like to request whether there is anyone in the audience who have not given the chit to the collection box. So with that, I once again welcome Tamban sir to felicitate our guest with her IIT memento.
I think all of you must have enjoyed the lecture. But the whole, I think the moral of the whole lecture, I feel, for you, uniformly applicable is that how inappropriate assumptions can lead to absurd conclusion. Is it not, sir?
Absolutely.
So this is applicable whether you are doing mathematics or engineering or physics or chemistry. So one has to be very careful about, blindly applying the method. Actually, mathematics is actually misused. As he said, statistics is also misused. Certain jokes are made about statistics. Similarly, lots of jokes about mathematics in general. But the main point is that you are looking at you are deriving conclusions by applying wrongly. So this is what I just want to say a few words. So, sir, it was very nice.
Oh, maybe he wants to pose again for a photograph.
Now I welcome Research Affairs Secretary Anand Krishnan to present our presider Tamban sir with a token of appreciation. And it's actually one of the RSD t-shirts. So I request our presider to just unwrap it and reveal. It's actually the first time we are showing our RSD t-shirt out. So.
Good question.
Yes, yes, sir. I request. It's like with this we are inviting Tamban sir to be a part of our team this year for RSD 2016. No, 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 sir. It's just a token of appreciation, like love from us. So after this we are going to have the lucky draw among the audience. So we'll be drawing out 3 chits. I invite Mr. Murali Krishna, GM, BSNL Chennai Telephones. BSNL is actually our power sponsor for RSD 2016. I welcome him to the dais. So our chief guest, and our guest will be picking out 3 chits actually, 3 chits. So the winners can stay here at your place and collect the goodies afterwards.
It's your prerogative. I have had my stage today, so.
So, okay, the first one to be picked is Ashwin RC. So Ashwin RC is here, okay. You please stay where you are. Meera Yadav is the second person, Meera Yadav. You can just raise your hand so that we know. You please remain at your place. Okay, third one is S. Bhuvan Chandra. So, okay, so it's like for every lectures we'll be having a draw and we'll be having exciting goodies. So please attend lectures. Please let your friends know. So it's like,
Good way.
thank you so much. So it's like, thank you so much for your time. Thank you so much. Meet you tomorrow 4 o'clock for ABB, and 6 o'clock we have another RSD lecture, all through till 10th, till 8th. And 9th and 10th is RSD days. One request to the team members, RSD team members shall stay behind. Kindly stay behind. All audience can leave the room. Thank you so much. Thank you so much for your time.